black and white.
Well, this one is also going to have color on it, so if you can just use a highlighter and highlight anything that you want to with the, instead of, I would just use black and white and then just highlight anything, okay? Okay, so again, here's our notes. I'll go ahead and make this larger so we can see it. And before I do that, let's go ahead and go over the questions that we have. So if you look here, first of all, it says, how does xy translate into x negative y? Describe a reflection across the x-axis. So we got to know how to answer that question. How does a reflection affect the properties of a two-dimensional figure? And then how is a reflection different than a translation? So when we do these Cornell notes, you should always refer back to something you've already learned, okay? And so we're going to refer this back to translation since they're a type of transformation as well. And so again, remember, a transformation is a change. All right, so let's go ahead and make this bigger so we can see it a little better. All right, so the definition of reflection. I'm going to see this is nice for me. A transformation that flips a figure across a line. So again, I am going to post these in the afternoon. So if you'd rather just pay attention right now, then just pay attention. But if you printed it out, you can do that, okay? All right. So transformational geometry, again, we're talking reflections. Translations, remember, was our slide. Now what we're going to do is flip the figure across the line. Okay, and that line is called a line of reflection. So right here, important, and I would highlight this lovely word important, because this is important to us. What's that, honey? Oh yeah, perfect. Yeah, I know, that's really hard to do, and I don't blame you. So like I said, I would pay attention right now. And then, yeah, you can write your answers, but I'm going to post this. So you will have this so you can look at it later. Okay. All right. So each point in this image are the same distance. Whoops, that's not mine. Same distance from the line of reflection. So again, we are saying that a reflection is a flip across a line. The line we refer to as the line of reflection, and it's going to be, our image is going to be the same distance as the pre-image, as the original, okay? So let's go ahead and look at our example. So the triangle shown on the grid is a pre-image. You will explore reflection across the x-axis and the y-axis is what we are doing, okay? So when I come over here, it says reflect the image across the x-axis. So I'm going to go ahead and I'm going to highlight the x-axis so we know that this is what we are going to go across. Okay, so this is what we are crossing. So that means that this shape is going to flip across that line. Okay, and so remember what is going to happen is it's going to stay the same distance. So if our line of reflection is this x-axis, and I look at the ordered pair for C, C's ordered pair is 1, 2, so 2, and then 1, 2, 2. So what's going to happen to C is it's going to reflect across the line, and it's got to be 2 away from that. So we're going to go 1, 2. So here's where the image of C would end up. So when I do the image of C, there's not much space there for myself. Let me try that again. The image of C is going to be 2, negative 2. Okay. A, his ordered pair is 2, 5. It's 2, 5. So that means that A's ordered pair has to be the opposite of 5. It has to be a negative 5. Okay. And then B, its ordered pair, 1, 2, 3, 4, 5, 6 is 6, and 1, 2. And so again, if we flip it over top of that line, it's going to end up in the negative area, right? And so it has to be the same distance. B is 2 away from the x-axis. So when we flip it, it's got to be 2 away from the x-axis. And so that means now it's 6, -2. That's the image. Okay, and again, we still have the congruent shape. The shape is the same, only now it's been flipped. Okay, so let's look and see what I wrote over here. Here's what happens. If we look at our original, right? So my original or my pre-image is 2, 2 for C. When I flip it, the x stays the same, the y becomes the opposite. Let's look if that happens to A. A, again, was 2, 5. The image of A is 2, -5. The x stayed the same, the y became the opposite. Okay. B, 6, 2 was its original, the pre-image, and then whenever I flipped over the line of reflection, the x-axis, it became 6, -2. Y became the opposite, x stayed the same. And so that's what this right here is telling me. Let me go ahead and get my highlighter here. Okay, so this right here, sorry, it's pink and it's not a good color, I guess. It's telling us that you're going to have your x and your y, and whenever you flip across the x-axis, the x is going to stay the same, the y is going to become the opposite. It's not the negative, it's the opposite. Okay, that's what that negative sign means, because if we were down below in the quadrant 3 or 4, it would be flipping up, and then we would be into the positive for the y's. Okay, so again, that little negative sign means opposite of what y is. And as we can see, that's what happened. Okay, I kind of want to highlight this pink so we know we're doing the same thing here. This is our across the x-axis. So what is the line of reflection for this translation or translation? This is not a translation thing. Sorry, guys. I should say reflection, so make sure you change that in yours. The line of reflection is the x-axis, or we could call this a transformation, not translation. On the right transformation here. Okay, so let's review this one more time. We're going to go across the x-axis. When we go across the x-axis, basically that means we're flipping the shape across the x-axis. When you flip the shape, we have to be the same distance from the x-axis. So every point has to be the same distance from the x-axis. C was 2 away from the x-axis, so that's why the image of C has to be 2 away from the x-axis, okay? A was 5 away, 5 units away, so the image of A has to be 5 units away, okay? That's what has to happen. So the next part, B, says let's reflect the image over the y-axis. So let's go ahead and look at the y-axis. The y-axis is right here, so anything now is green because we're going across the y-axis. Same holds true, okay? When we flip, each point has to be the same distance away, so same amount of units away. A is 2 units away from the 2 units away from the y-axis. So that means that when I flip across the y-axis, I still need to be 2 units away. So let's go ahead and flip. So A is 2 units away. I'm going to go ahead and I'm going to go 2 units away again. A's image. Okay, C is 2 units away from the y-axis, so C has to be 2 units away from the y-axis. And then B is 1, 2, 3, 4, 5, 6 units away. So 1, 2, 3, 4, 5, 6. The image has to be. So again, the shape that I just created, I didn't make it bigger, I didn't make it smaller, I flipped it. Okay, so it looks different. Remember when we translated, all it did was slide. We flipped now, so it does look different, but it's not, it's still congruent, okay? It's still the same. All right, so let's look and see what we have. I'll go ahead and write my ordered pairs again. So we already know A is 2, 5. Well, let's make this 2 lines. I'm going to say this is a double, so we know which one we're talking about. Okay, so now when I look at A, its ordered pair is 1, 2, negative 2, 5. When I look at B, new image, it goes 1, 2, 4, 5, 6. And 2. Whoops, that's negative 6, right? We went backwards. And then C is back 2 and up 2. All right, so let's go ahead and look at this information. We'll compare it to the original. So again, the original is right here. The original was for C was 2, 2. When we do our reflection, it becomes a negative 2, 2. Okay. A, the original was 2, 5. When I come back over here, I'm a negative 2, 5. And then when I look at the original for B, I was 6, 2, and now I become a negative 6, 2. So when we go ahead across the, whoops, let me highlight this in green so we know this is the reflection here. So what we should notice here is that when we reflect the image across the y-axis, what happened to me? Oh, I know what happened. Let's do this. No, of course not. It's obviously there. All right, well, again, my ordered pair should look like this. We started off with x comma y, and now we end up with a negative x. Not negative x, but opposite of x. So if x was a positive, it now becomes a negative. If it was a negative, it now becomes the positive. So make sure you understand that this little negative sign right here is telling you opposite. Okay, that's what that means. Same thing with this one. That means opposite. Again, we're transforming across the y-axis here. I could highlight this in green so we know what on my paper. Anything that you see in green means the y-axis. Anything you see on my grid here is pink is the x-axis. All right, so let's go ahead and look at this figure here. The figure shows the trapezoid, TRAP, graph the image of the trapezoid after reflection across the y-axis. So we are going to go ahead and cross the y-axis. That's what we need to go across, okay? So you see how I highlighted it? Doesn't hurt us to highlight it. Now I need to know, again, remember, same distance. So if R, we can see, is 2 away from the y-axis, that means when I reflect R, it has to be 2 away from the y-axis. I'm going to go ahead and reflect it. There it is. Okay. A, 2 away from the y-axis. So when I flip it across the y-axis, that line of reflection has to be 2 away. T, 1, 2, 3, 4 away from the y-axis. So T is going to be 1, 2, 3, 4. The image is also going to be 4 away. And then P is 4 away. So that means that 1, 2, 3, 4, my image of P, 4 away. According to our notes, whenever we are crossing the y-axis, right, what did we say? Our x is going to become the opposite, the y will stay the same. So let's see if that held true. When I come here and I look at point T, the original point T was located at 1, 2, 3, 4, negative 4, positive 6. The reflection is positive 4, positive 6. So the x did become the opposite, the y stayed the same. See how that happened? All right, questions? No questions? Pretty simple, right? All right, so what I want you to do is I want you to look through these notes. I'm going to go ahead and I'm going to make it bigger again. On the bottom of this page, I did put a place for you to write a summary. So you can go ahead in here, and I want 2 to 3 sentences about this information. Again, when you are writing these sentences, I want to see it answering the questions that are on the side. Okay? So answer these questions. This is what we are learning. So you should be able to tell me, how does that reflection across, how does xy to x comma negative y describe what is happening when you cross the x-axis? How does a reflection affect the properties of that two-dimensional shape? So what happened to our two-dimensional shape? Did it change? They didn't change, did they? All it did was flip over. It actually still a congruent shape, okay? And then how is reflection different than a translation? So talk about that. So you can go into this page and you can write your summary. That's what we're going to do for the next 3 minutes of class, okay? And then tomorrow we'll work on the practice. So don't worry about the practice. It's not homework. We are just going to go ahead and work on it in class tomorrow, okay? All right.